And today I'm going to talk to you about observability and the data analytics paradigm shift. And let's see that my clicker would connect to the computer. Why is that not working? Just a second there. Okay. No, it's just a matter of the pairing. Let's make sure that it is paired. Okay, that should be okay now. And who has seen? Okay, that was supposed to be okay. Let's do it like that. Who's seen this Venn diagram definition of observability? Anyway, with a show of hands. Okay, everyone. So essentially, in a nutshell, I'm here to tell you that this is not the definition of observability and that I hate this Venn diagram. And I'm going to tell you why soon. My name is Dotan Horovits. I'm the principal developer advocate at logs.io. Logs.io provides a cloud-native observability platform that's based on popular open source tools such as Prometheus, Jaeger, OpenSearch, and others that you probably have heard throughout the day and tomorrow, especially here on the observability track. I'm also a CNCF ambassador. CNCF is the Cloud Native Computing Foundation, where Kubernetes and many of these projects reside. And I also have a podcast called Open Observability Talks. So if you're here in this track and in this talk, you're probably interested in the topic, check it out on your favorite podcast app. Cool stuff there. And you can find me everywhere at Horovits, as you can see, Horovits. So if you are tweeting or tooting or posting anything interesting out of this, feel free to tag me there. And let's talk about observability. Okay? We all know the classic definition of observability that is, in fact, taken from control theory, from applied math, essentially, so not even from computer science. And the definition is a measure of how well the internal states of a system can be inferred from knowledge of its external outputs. And I hate this definition of observability. And I'm going to tell you why. But first, let's understand what this definition means in the context of software systems. What are these external outputs in this definition? Anyone? Sorry? Metrics, traces, logs. Exactly. So what's known as essentially the telemetry that our systems emit is primarily the famous 3 pillars of observability. And, as you might have guessed, I hate the definition of 3 pillars. And I'll tell you why soon. But first, let's understand these pillars or these signals. These telemetry signals, logs, metrics, and traces, are, in fact, very important for observability. They help us understand what happened, why it happened, and where it happened in our systems. The typical flow is that metrics help us detect that something happens, a service went down, an endpoint is slow to respond. Things like that will show up in the metrics, typically coupled with alerts that we define on top of these metrics that alert on that. Then logs tell us why it happened, because frankly, as developers, we probably know that. Developers put a lot of information into the logs that in their code. And then traces help us understand where it happened within this chain of interacting microservices, in this distributed transaction that occurred. So logs, metrics, traces, these signals are indeed very important for observability. However, they are, by themselves, not observability. And in fact, many users, and I see that day in and day out, diligently collect these signals and then end up with broken observability. And actually, who found himself in the middle of an incident with poor observability even after collecting all these telemetry signals? Be honest. Okay, look around you. I'm not the only one there, so that's good news. But the question is, why is that? Okay? So going back to this definition, the traditional definition of observability. The classic definition of observability puts a lot of emphasis on, as you can see, on the external output from our systems, which is essentially the raw data. And the other part in this definition is often overlooked. This is the inference part, the insights out of that data. So I use a different definition for observability. So for software systems, of course, behold the new definition. Observability is the capability to allow a human to ask and answer questions about the system, based on the telemetry that it emits, of course. So the capability to allow a human to ask and answer questions. Now, why do I like this definition better? The first reason is that it makes it very clear that observability is essentially a property of your system, okay? It's not something that you can bolt on in the aftermath like in traditional monitoring, but something that needs to be there from day one as part of your system design, what I call observability-driven development. And I'm going to show you how to actually implement observability-driven development in practice. So that's the first reason I like this definition better. The second reason I like it better is that it makes it very clear that observability is a data analytics problem. The more questions we can ask and answer about our system, the more observable it is. Okay? A system as simple as that. And so logs, metrics, traces, these are all very important, but it's just the raw data. What we're interested are the insights to understand what goes on in our system. It also calls for a different mindset. Okay? It's not the reactive monitoring and maintenance mindset that we used to see in the past, but rather, I'd say, a data analyst mindset to proactively ask questions and query what goes on in our systems, to be able to formalize ad hoc questions and align with things that come up in the incident that we haven't anticipated before, what some people call the unknown unknowns. Okay? So this is the data analytics paradigm shift in observability, and this is the topic for today's session. So, okay, Dotan, you gave us a new definition for observability. That's fine, but what does it really mean? What is observability really about according to this paradigm shift? And I'd like to go over several important points that you'd like to, you should consider in your observability practice in a data analyst mindset. You can see here, as time permits, I'll touch about collecting data from different sources, formats, and types, structured, standardized data, enriching and correlating, and more. I'm saying up front, this is a lot of ground to cover, but I'll share links to deep dive into each and every one of these topics. So keep the lookout for QR codes on the slides where you can find very useful links for deep dives on each one. Let's go straight to the first one. Observability is about collecting data of different sources, formats, and types. I'll take the questions at the end, if you don't mind. I'll leave some time for the end. Sorry. You'll see QR codes on some of the slides. It will be very, very visible. But I promise I'll point it out when I get there. No worries. Thanks for the insight. So observability is about collecting data of different sources, formats, and types. So metrics, logs, and traces, or MLT, as some call that, that's the classic signals. But there's no reason to limit ourselves to just these three. I know that we humans tend to favor the rule of three, but there's nothing holy in this trinity. And some other types of raw data may come up as useful for different use cases for observability, and we should be flexible enough to incorporate these into our system. And indeed, you see that in conversations going on in this domain, in this space. People started talking about, you see from 2021, a discussion about MELT, adding events to the mix. This is, by the way, Alolita Sharma, a very senior at Amazon and now at Apple. And then discussion came, you see, from 2022 from Yuri Shkuro. He's, by the way, the author of Jaeger tracing, open source by the CNCF, distributed tracing back in the day at Uber, now at Meta. So he talked about 6 signals, aptly called tempo, which added to the mix also exceptions and profiles, continuous profiling. And in fact, continuous profiling in particular seems to gain a lot of momentum. I don't know if we see many entrants in the space. I don't know if some of you followed. Just last week, Intel released their profiler, the G profiler, to open source under Apache 2.0 license. That's part of their acquisition of a startup they acquired a couple of years ago, Granulate. And then Grafana Labs acquired the Pyroscope, and Elastic acquired. And so lots of M&As also around continuous profiling, lots of activity. Just to know, who knows what continuous profiling is, with a show of hands? Okay. Does any one of you use that in production, in systems? Okay, so we have 2.5. So I'll say a word about that. So continuous profiling is like the traditional profiler we probably know from Java, .NET, whichever programming languages you use, that we use to connect, but that was a one-off. Continuous profiling does that on an ongoing fashion, and that's an excellent way to see where we spend most of our CPU or memory in our app, where out of memory comes from, and map performance down to the specific function and specific lines of code within our app. So very useful for performance, for cost, and for other use cases. Usually, this is what you see on the here on the screenshot is a flame graph from improving RabbitMQ using continuous profiling. So a flame graph, you probably see why it's called flame graph. It looks like flames. Is the classic view for visualizing the different call stack and how much it took, like the width of each call. And it's a nice complementary to metrics, logs, and traces. I promised you QR code, so we have here, if you want to read more about continuous profiling and how it fits into the observability stack that you do know, that's a great place, because many of you said you're not familiar. A very good introductory on that topic. And I'm glad to say that OpenTelemetry also identified continuous profiling as a key signal to add to the stack. And back in 2022, you see here, we had the initial extension proposal, and a lot of work has been done since. Last year, back in September 2023, the data model for profiling was shared, the first version, along with prototype implementations for the client libraries and collector. Quite influenced by pprof, for those who don't know this specification for profiles by Google. And the hot news from last month, behold, the data model, or the extension proposal, OTEP, was merged into OpenTelemetry. So that's big news. That means that continuous profiling is now an experimental phase, organically part of OpenTelemetry, a fourth signal in OpenTelemetry. Great milestone, happened really last month, as you can see. A remarkable journey led by the SIG profiles, a special interest group that was inside the CNCF, and actually hosted the members of the SIG profiles on my podcast, Open Observability Talks, for a special live stream panel just last week to talk about this important milestone, what we've achieved, what's the roadmap ahead. So check it out, follow the podcast, Open Observability Talks. The episode should be coming out within a week or so. And definitely profiling will be a major enhancement to OpenTelemetry this year in 2024. And I'll talk more about OpenTelemetry later in this talk. So if you're not familiar, I had a whole talk about OTEL yesterday at KCDLA on the co-located event, but I'll definitely say a few words. So if you're not familiar, don't worry, I'll say a word about that soon. So that was about the signal types. But it's not just about signal types, but also about the sources. Okay? As you can see here, observability involves the ingestion of signals from many sources. You may find yourselves ingesting data across different tiers, across different frameworks, across different programming languages. In this, for example, you can have a Node.js front end with a Java backend, and maybe a Kafka cluster and a Redis cache and a Postgres database and some cloud services. That's pretty typical, right? And consistently collecting this heterogeneous data across so many different sources, formats, and types has been a challenge for a long time, because each programming language and each tool and each vendor has its own way of instrumenting the application, and its own way of collecting and processing, and its own way of transmitting. And that, what's the biggest problem about that? Standardization could be a solution, but what's the problem? Again? The lack of interoperability, that's right. So if we remember, we're here to talk about data analytics mindset. So in a data analytics mindset, the problem is very simply that it creates data silos, okay? And then it makes it very difficult, as the fellows here said, to correlate between these silos and ask cross-cutting questions to understand what goes on in our system. And that's, as we said at the beginning, that's the essence of observability, the ability to ask and answer questions about our system. And this is where OpenTelemetry comes to help us. So, as I mentioned, I gave a whole talk yesterday, but I'll just say very briefly, OpenTelemetry is an open source framework, observability framework, for generating and collecting telemetry data across different signals, across different sources, across different types, in a vendor-agnostic, unified, and standardized manner. It's a project under the CNCF, the Cloud Native Computing Foundation. In fact, it's the second most active project in the CNCF after Kubernetes itself. So, and big news from last week. I don't have that in the slides. I talked about it yesterday. Big news from last week. The project has applied to achieve graduation under the CNCF, to be a graduated project. So a very, very major milestone for the open source project. What you see here in the picture is the OpenTelemetry collector, a very important component of OpenTelemetry for collecting, ingesting, and processing the data. As you can see, it's built like a typical data processing pipeline. So you have receivers in multiple protocols, then you have processors, and then you have exporters in multiple protocols. So if you want to ingest telemetry, logs, metrics, traces, and so on from your front-end app, your back-end app, also all sorts of infrastructure, like, you have a Kafka receiver, a Docker receiver, a Kubernetes receiver, and so on. You just plug in the right receiver, also AWS, X-Ray, and others. So really a very rich suite of receivers depending on where you collect from. Then you have different processes to do things such as filter, batch, sampling, and so on, that you can chain to get more elaborate logic. And then you can send off the data, export the data to your backend analytics of choice. You have AWS X-Ray, you have Google Azure Monitor, you have Datadog, Dynatrace, Splunk, my company Logs.io as an exporter. Of course, you can downstream that to Kafka if you want to process that as an event or something like that. So really a rich suite of exporters. And you have a QR code again for a guide to OpenTelemetry if you want a more comprehensive one. And OpenTelemetry, by the way, is not just the auto collector. It has other components. The collector is the green part in the middle. In addition, you have client libraries. That's the blue part at the left-hand side. You have per programming language, you have APIs, SDKs, you have auto instrumentation agents, and so on. And then you have also OTLP as a standard OpenTelemetry protocol for transmitting that data. So that's really in a nutshell. And as I mentioned, you can find on the QR code the guide and also sub-guides per programming language if you're interested in a specific programming language and how to get started there. Observability is about structured, standardized data. Who still has this kind of plain text, unstructured logs in his system somewhere? With a show of hands. Okay, we all have in some way, or even the ones that I suspect the ones that left their hands down. And I'm here to tell you, don't, okay? Don't forget about the unstructured plain text logs. No human is going to read through your mounts of log lines to figure out what goes on in your system and extract insight. Remember, we're here to talk about a data analytics mindset, okay? So what we need is structured and machine-readable logs, something like JSON, protobuf, that machine-readable format that we can then use machines. We can use software to analyze it at scale. So the best practice is to send structured data, and remember, observability is a property of your system, so put thought into what is important to be part of your logs. This is the observability-driven development that we talked about before. Think about schema, think about the fact that all the relevant data will be part of your logs. And also make sure to use consistent conventions across your logs. Don't call it user underscore ID and then user camel case ID or things like that, or customer ID in some place. Apply observability-driven development also in the specification and the conventions. And one very important point in large organizations, platform engineering can actually play a central role in creating these standards and maybe even embedding them and automating these so that the developers don't need to be bothered with that at all. Actually, we had a very interesting talk this morning by eBay on this track that they shared how they do that across the company and across the front-end and back-end tiers automatically, so developers are not even aware of that. So if you have platform engineering team, pull them and bring them on board in terms of these conventions. So that's a good start. But we said before that we have many third parties in our system, right? I gave examples, Redis and Kafka and whatnot. So the question is, how do we make sure that the same data model and semantic conventions are followed across the different pieces of our technology stack? And one of OpenTelemetry's goals is actually to standardize on a structured and strongly typed and machine-readable format for logs. And exciting update from last KubeCon last year is that ECS, Elastic Common Schema, is merged into OpenTelemetry semantic conventions for logging. So all the aggregated knowledge from the Elasticsearch community is now part of the logging semantic conventions in OpenTelemetry, which helped us reach the GA for logs. So that's great news in logging side. On the metric side, we have OpenMetrics, another open source project or specification under the CNCF, the Cloud Native Computing Foundation. For metrics, it's actually started from the native format, exposition format by Prometheus. Now it's its own project, independent project. And the nice thing, you know, the adoption for Prometheus, the nice thing that is pretty much de facto standard that most of the stack that you have probably running in your system has out of the box /metrics endpoint that you can expose with this format. So Kafka, RabbitMQ, MongoDB, Apache, Nginx, Jenkins, Jira, whatnot. If you have it, check if they already have a flag that you can turn on and you have it by design. And there's exciting news, by the way, about this. We've applied to get this as a formal standard under the IETF. There's an open RFC for making OpenMetrics an official IETF standard. So again, check out the QR code for these updates about the open specifications and open standards in observability and these latest news in the QR code. Observability is about enriching and correlating data. So like you probably know from data analytics, data enrichment is an important step and of actually adding metadata, right? And adding metadata such as the user ID or the build number to your logs, like in this example, can greatly help map the log to the root cause. So think about things such as a customer-specific issue, like the example I gave here, or problematic build, and how much easier it is to do the root cause analysis when you have these enrichment metadata part of your logs. And remember, effective data enrichment can turn your logs into meaningful events. So once we have the metadata on our telemetry, we can apply data analytics on them, the filter, group by, and so on, to investigate only the specific pod, the specific namespace, or whatnot. And data enrichment is not just part of logs, but also metrics. So here's an example from Prometheus Service Discovery, Prometheus SD, mechanism that knows a lot about the scrape targets. And what it does is it takes this data that it knows and then makes it part of the metadata as labels on the metric. So you can see here a few examples of labels that are added. In this case, this is the Kubernetes node metadata added by the Kubernetes SD. And I mentioned the open specifications. So open telemetry specification also has attributes, as it's called in OTel, essentially key value pairs that help us represent signal attributes, instrumentation scope attributes, resource attributes, and so on. In this example, OTel collector has a Kubernetes attributes processor. Remember, we talked about in the collector a processor. So there is a Kubernetes attributes processor that allows to automatically set all these different types of span, metric, data, logs, resources attributes with Kubernetes metadata. And the processor automatically discovers the resource and extracts the metadata and then add them as relevant to the relevant spans, metrics, and logs. Part of the advantages of OpenTelemetry covers all the signals, that these the same consistent metadata will be added to logs. Spans is the pieces of the trace, okay? So this trace data and metrics. And that's the case for Kubernetes. Of course, the similar use cases are available for cloud infrastructure, bare metal, and so on. So this is just a Kubernetes example because you can't go about doing a lecture without mentioning Kubernetes, right? We also use data enrichment to support correlation between the signals, okay? And the common best practice is to add the trace data to your logs for easy trace log correlation. And even better, you can actually emit your logs as part of your trace data, as part of your spans. Because if you think about it, each service operation invocation emits a span for the trace, and then it emits a log to say something. So why should we actually emit two different signals to say what went on in the service operation invocation? We can just emit the logs as part of the baggage of the span data, and then it inherently is contextualized to that specific operation in that specific service in that specific request execution. Okay, so if you do use traces, definitely something to consider as a best practice. And check out the QR code as a guide I wrote about how to use metadata effectively in Kubernetes and other environments. So in conjunction with different telemetry signals. So a useful guide there. Observability is about unified query and visualization. So you probably found yourself in this situation in front of different screens, looking at different views. And the thing is that data analytics paradigm requires the ability to query data across the different signal types and across different sources and draw the relationships between them. But the problem is that the market is highly fragmented. So you find yourself, as I mentioned, looking at different screens and also using different languages to query. So you use Lucene to query your logs, or maybe LogQL, and you use PromQL to query your metrics, or maybe InfluxQL or something like that. And you have the vendor-specific, the NRQL for New Relic, and the DQL, I think, or whatever it's called for Dynatrace, or each one has its own. And this fragmentation is, again, a problem for data analytics. It all comes down to data analytics. So what's the answer? And to be honest, there is still no good answer canonically. There's a good start under the CNCF with a new working group under the Technical Advisory Group for Observability that was formed to standardize a query language for observability. I cover that in my podcast as well, so check out this episode. You have the QR code here with a member, the creator of this standard, and it's a good start. It's a good beginning, but I have to be honest with you, we're still far ahead with that, and even farther ahead in standardizing the visualization part. So what can we do? The answer is, or the best practice is, to create your own organizational standards. Essentially to make sure that you can query across data types and to visualize them together as much as possible. And also here, as I mentioned before, platform engineering can play a key role in creating these organizational specifications and standards and unification. Observability is about data volume and data to noise ratio. So like in any big data analytics case, you quickly find that your data volumes explode and become expensive to scale out, right? And you also quickly find that much of that data is not useful for you. It's really pretty much noise. So let's see how we can apply observability-driven development to carefully consider the value of our data. And let's start with logs. Logs are the most verbose and storage-intensive signal, textual. So the first tip is to think which logs you really use in real time to understand, to troubleshoot your system, and which ones you don't really need. Like I see sometimes I go to users and I see them persisting debug logs, for instance. So no, don't. And if these logs are used but they're rarely used, like for auditing, for compliance reasons, so you might want to just store them in some S3 or cheap storage, like object storage, something like that, just for this once in a blue moon, and not on your expensive observability, primary observability store. And if they are logs that you use, okay, you use for troubleshooting, ask yourselves if you use these logs essentially as metrics. And I brought this example, this Cabana visualization for HTTP status codes. And if that's what you actually are doing, like just checking the frequency of the 200s versus the 400s versus the 500s and that's it, ask yourselves, why not just roll up these logs into metrics, into time series data, throw the raw logs, and just keep the time series data. It's much, much more efficient, much more compact, but also much easier lends itself for querying metrics, right, with PromQL and other ways to do that. So definitely something to think about. And for logs that you do see need to keep the raw logs for troubleshooting, ask yourselves how long you need to keep them for, okay? In most cases, for troubleshooting, you use logs, you look back a few days at most, definitely not over a week. So determine your own retention period, and after that, just throw them, evacuate them, clear them. If you're not sure if you would need them later on, so just maybe periodically archive, do roll-ups, archive them again into S3 or something cheap, and don't keep them on your main part. So again, QR code at the bottom for those who don't see, for some best practices around logging and optimizing costs. Now let's talk about metrics. People tend to think about metrics as something cheap because it's just numerical data points, but you'll be surprised to learn that they exponentially build up with high cardinality, with many labels that you have on the metric. So a few best practices. First, high cardinality is an issue. So and what happens, what I usually see is that with each incident that happens, we do the retrospective, the postmortem, whatever you call it in your organization, and then we could use some additional label on this metric that could have helped us here. Let's add that. And people don't understand when you add a label, you add it across the board, so it's a whole dimension that you add. and then it builds up. So again, observability-driven development, think which labels you need on your observability. I brought an example here. Sorry about that. On the screenshot, you can see Kubernetes metrics with 30 labels, if you can see here, and taking up 1.3% of the data volume, although it has only 537 unique time series. So how come it's 1.3%? Probably because of the cardinality, okay, because of the labels. So, and this is not a rare case. So think about it. If you don't need some dimensions, don't send them. Remember, observability-driven development. But in some cases, and Kubernetes, again, is a very noisy example. Kubernetes gives out a lot of labels there. Then you can just roll them up on the ingestion side and remove unneeded dimensions, do downsampling. For example, in our case, in our system, for example, we just created a way to very simply look at all the labels. You find the labels that you don't need, click, remove, roll up, and that's it. So consider if you really need. If not, and if you can't control the third party to remove it to the source, just remove it upon ingestion. And another important point, it's not just about the number of dimensions that you have, but also the size of the dimensions. So having a label for, let's say, the region is fine. You'll probably have, I don't know, 10 regions, 20 regions, it's fine, a few dozens. But if you add wide range dimensions, or maybe even open-ended dimensions, like, I don't know, user ID as a dimension, not exactly a good idea, okay? Another anti-pattern, be careful of wide dimensions. Another very important, very typical thing that I see, surprisingly, but not surprisingly, I often see that in most organizations, the vast majority of metrics are actually not being used anywhere, in any dashboard, in any alert rule, anywhere. And actually, I saw stats talking about 75% of the metrics that are never put to use in any dashboard or alert rules in Kubernetes environments. And again, that's the problem, especially in Kubernetes. There's a ton of out-of-the-box metrics, and each time they add more, and there's a bloat of these metrics, and people just use the defaults. They don't think about what they need for their system. They just take the out-of-the-box, and the defaults are noisy, okay? So again, observability-driven development. Think about what you need for your system, for your troubleshooting, and don't keep metrics that you don't need, or just throw them. This is how we did it in our UI. You see a metric with, what's the size here? I can't see the size here. Anyway, it's like 22 labels, taking up 0.6% of the data volume, flagged unused, click, drop, remove that, okay? Observability-driven development, think what you need. And again, QR code for those who want some more best practices in metrics essentials, how to reduce the noise in expensive metrics and reduce the costs. A very useful guide, part of my metrics essentials series. So I want to summarize what we've seen here. Observability is it's a data analytics problem. If there's one thing to take out of this talk, remember this: observability is a data analytics problem. And this is the definition that I suggest using. Observability is the capability to allow a human to ask and answer questions about the system. There's an article from Inside Big Data. You have the QR code here about observability as a data analytics problem that covers that in great length. So you can check out this article in Inside Big Data. We covered quite a bit, so just to wrap up quickly, collecting data of different sources, formats, and types. So we talked about not just logs, metrics, traces, but about other signal types like events and continuous profiling, also across different data sources, formats, programming languages, front-end, back-end, app, infra, cloud services, and so on. We talked about structured, standardized data. Forget about unstructured flat file logs. Go about structured, machine-readable logs. We talked about enriching and correlating data, adding metadata to turn your logs into meaningful events, and to add metadata for cross-signal correlation, like trace ID to logs and things like that. We talked about unified query and visualization to reduce the number of query languages and different visualization tools, and that you need to ask cross-cutting questions. We talked about data volume and data to noise ratio. Think about what you need. Don't keep what you don't need. Think about which labels you need on metrics, where you store your logs, how to roll up the logs. Remember that high cardinality metrics are exponentially expensive. And if you want to read more, again, the article in Inside Big Data gives also a good view on this. So with that, I'd like to wrap up. I'd like to thank you, and may the open source be with you. And now, happy to take the questions, just with the mic so that the stream can also get your questions.
Yeah, my question is around standardization, specifically working with like an enterprise system where you have legacy code or legacy data, you have other microservices, and maybe even have like third parties services that you're scraping from. And I guess what I'm trying to understand is like what exactly would you be standardizing? Because all of those are going to be different data types, going to be different like names, but it's all going to be the same data. And I think I'm struggling to figure out like at what point can you standardize that?
So the two parts in here. One, the code is under your control, where I suggest converting the organization as much as you can to the new formats. And then there's the legacy, the third parties that you can't change in the source, so they'll probably carry on emitting, I don't know, traces in a Zipkin format or logs in some other format, and then you can do that upon the collection. And that's part of the advantage of having something like the open telemetry specification, which contains also semantic conventions for logs, for anything essentially. And then once it's ingested using open telemetry, it can then be canonically moved into OTLP. That's the Open Telemetry Protocol that has the canonical data model. So from that point on, from the ingestion point where it goes being transformed to OTLP, onwards, the rest of the processing and definitely exporting then afterwards to your backend analytics will already be upon OTLP and the standardized data model. So that would be my advice. Obviously, it's an evolving standard, but that would be the way to go.
I have one more question, if that's
Certainly.
Okay. The idea of aggregating like similar values seems like something that would be better use for like an AI, and so you wouldn't have to like manually pick things around. Is that something that's a possibility?
What do you mean when you say aggregating similar values?
So like the two cases you had were like snake case and camel case, for example.
Oh, okay.
That's like the most basic form. But then there's also like IDs. I've seen them in strings and numbers. And so manually going through and like creating that graph of association seems really tedious. And it would seem like AI would be a better solution for that.
I'm in favor, but it's not something that is currently part of the standard tools. I know that I can tell you that, for example, my company logs.io has some of these capabilities as part of the tool. Other tools have similar, so it's definitely something that has been looked at in the industry to apply either as an advisory capacity, at least flagging, hey, is that the same, or even converting it automatically. But it's something that currently is not standardized, so you don't have it as part of, for example, OTel, but it is something, for example, that you can contribute or develop it for your own organization as a processor, for example, that can ingest and then do some sort of a pre-processing phase where you align it based on AI. So it's definitely something that I encourage you to actually maybe look into that as part of the canonical OTel processing stack. More questions. And by the way, whoever asks question, get a sticker. May the open source be with you. So So you get the sticker and encouraging you to do that. Here you go.
So you have this diagram that shows collectors on one side and basically data storage on the other side. There was an early slide in your presentation.
For the OTel architecture?
Right, right.
Okay.
And then in between there's processor 0, 1 to N. What actually are those processor things? Is that another tool, or is that something you have to make yourself, or is it where does that come from?
So the diagram is part of the OpenTelemetry collector. And the OpenTelemetry collector is a single component within OpenTelemetry open source project, but it's a tool for all sakes and purposes. So you can think about it like Telegraph, if you're familiar with Telegraph, or like FluentBit or FluentD. These sorts of collectors, daemons, agents that already exist, like Elastic's Logstash, for example. I don't know what you're familiar with. So very similar to that. And it's built like a data processing pipeline. So you have receivers and exporters in multiple protocols. And in the middle, you have processors, that's how it's called in OpenTelemetry, that can execute sorts of logic. For example, the logic that the lady here suggested is, let's do upon ingress some sort of normalization of the data labels. Another processing could be filtering. You can say, I need to clear out PII data. So this could be another processor. It could be batching, like collecting and then creating into batches and it could be sampling. So these are the processors that you can chain together also for more elaborate logic.
So are those predefined things, or are there examples, or is it something you make yourself from scratch?
The answer is both. So OpenTelemetry is a framework.
Yes.
So it comes with the facilitation of running and chaining processors into pipelines. Essentially, you create a pipeline from the ingress, from the receiver, all the way to an exporter through processor chain. Some of the processors are out of the box as part of the vanilla upstream contributions. There's also the contrib repo, where external companies or entities can contribute others, and you can also create your own library. I think, again, the gentlemen from eBay, they have their own logic that they developed in-house for themselves. They're not even contributing some of that upstream. So it's modular enough that you can create your own processors or take vanilla processors and tweak them for your own needs or any other thing.
Okay, good. Because you had concrete product names listed on the left side and right side.
So it's my bad. It was essentially just to show examples of what kinds of processing. And so I said, and even these are not formal names. I said filtering, batching, sampling, things like that, but just to get it more concrete for people to understand what kinds of processing could be implemented. But lots of that. One of the things that, for example, we donated to OpenTelemetry at Logs.io was a span metrics processor that actually takes span data, which is trace data, and rolls them up into metrics, red metrics, request rate, error rate, latency, and then emits, in addition to the raw spans, also emit metrics. So you can get sort of an APM-like red metrics on your microservices. So this is a type of a processor that actually forks the traces and creates metrics from the same raw ingest, creates an extra egress for time series data.
Okay, thanks.
So I couldn't help but see two potential pitfalls in regards to trying to incorporate some of these elements into some previous shops that I worked at.
Okay.
One of the major ones that I'm very curious to hear your solution to is when you're looking at dropping specific attributes, or for when we're needing to deal with data flow, and we have these very specific categorizations to identify per compliance, right, whether or not it's supposed to be going here, if it's supposed to be seen there. Dropping those elements and then having a team be like, oh, then if we can't see that, then it's not going to be part of our budget. And then you indicating, oh, it's only 1.5. Oh, so then we only need to contribute 1.5% of whatever that cost. How have you dealt with that?
So I said you drop things that you don't need, and what you're saying is a very clear need. The need, maybe one point that I do take, and it's important, that maybe the view that I showed, which is about where it's being used, is based, or at least the view that I showed, is based on if it's put to use in dashboards or alert rules. okay, or recording rules. What you're suggesting is a third consumer, let's say, which is, let's call it compliance. So what you need is to flag compliance as a usage, and then it should flag. So when I said it's not used anywhere, if compliance is one of them, that it's not anywhere. What I'm saying is just make sure, again, mine is only an example. You know what your consumers are, and compliance and auditing is definitely a consumer. The CISO team in your company is definitely an important organization. So just make sure when you map the consumers, this is part of the consumers. And just record that. Make sure that this is recorded not on a wiki page or something, but really automate that. Make sure that there is a table that it can be accessed and say this metric, this label, this field is being used by this compliance runbook or script or whatnot, so that it's tracked. And as long as it's tracked, you can see that it's still used. Even better, map and make sure who is this consumer, so that if you have any doubts, go to that source and make sure, are you still using that? Is that still relevant? But a definite consumer, and make sure that if this is a stakeholder in your organization, it should be clearly mapped. Good point, thank you.
Just a quick question. I think you might have answered that during your answer for the first question, but I would like to know, this question is in regards to enriching and correlating data. So you said something about correlating, doing some correlation between the metrics and the traces and even, your logs. But I would like to know on a more practical, situation, and how you do that, or how you do that when you have when you're using three different, backend tools. You have one for your metrics where you send your metrics. You have the other one where you're sending your logs, and you have another one when you're sending your traces as well. Or maybe the solution to that is to just have one, backend solution where you are getting, you're emitting all your telemetry data.
You're asking specifically about mapping metrics to traces?
Yeah,
metric trace correlation?
Yeah, correlating that during like probably like an incident or what. Yeah.
So it's not, let's separate the question between the backend and the processing. For correlating, in terms of the metadata, which is what I talked about, the metadata is nothing to do with the backend. It means that you have sort of an additional data, metadata attached, that helps the correlation. For example, you have the log, and then you have a trace ID that helps you jump to a relevant the trace where this log happened, okay? Or metrics, maybe I should have mentioned that. For metric trace correlation, there's something that's called exemplars. So on the metric, and there's a mechanism built into that, actually both OpenTelemetry and Prometheus embedded that as part of the specification. So both of them support that. You can have the metric, and then you can have an exemplar trace, like the trace ID, attached to the metric. And then if you want to see, okay, I see a spike here, suddenly I have, high latency. I want to see an example trace of a request that behaves like that with a high latency. So the average latency is 0.1 second, and suddenly you have 10 seconds. I want to see an example request that behaves like that. You want to, like visually, if you think about it, I want to click and see a trace, right? So I'm leaving aside just a second the click, but the attachment of the metadata of a sample trace is something that you can do as part of the specification. As I mentioned, both OpenTelemetry specification and Prometheus specifications support exemplars. So that's on the metadata enrichment side. Now, the other part of your question is, but how can I do this experience of clicking and seeing that? Or how is my backend analytics tool making use of this exemplar in this example? And many of the tools today already have facilitation for supporting this, this capability, okay? So I can give you an example, for example, from my company, from Logs.io. You can look at a metric, and you have sort of a button there. You just click on the spike, and you want to say, I want to see exemplar, and it will switch over to and show you a trace, like the timeline view that the Gantt chart that we all experiment to see an example trace. And same for trace to log. You see a trace, suddenly you have a span that is very long, like an operation that took a lot of time. You want to see more information than what is inside the logs. Of course, if you pack the logs inside the span, that would be best, if you remember my best practices, but many of us don't do that. So you want to be able to have a click and say, show me the log, and then it will switch over to a Kibana visualization to see the logs. So this is the backend experience, but this depends on the tool. But once you have the metadata in a standardized format, then you have the tools that support the standard, and then you can have this unified experience on the backend. If you still use separate tools, it could be a bit awkward. So if you use, let's say, Prometheus, there's no logs in Prometheus, of course, then you need to switch over to another tool. So that's a place where it could be a bit of a friction if you have siloed tools that, again, tools that are vertical and not a full observability platform. So that's
Yeah, thanks. First of all, I think you made a great presentation yesterday with what's new on OpenTelemetry and Kubernetes.
Yeah.
And congrats on the move for the OpenTelemetry and the graduation. And
Thank
I think
you.
this also presentation, I agree 100% with the observability and data analytics problem. My question has to do a lot with the second question that was asked by the front person there. Today, one of the problems that we have for data analytics and observability is the structured data, right?
Structured data?
Yeah, structured data. And when you have like quite a bunch of vendors that you cannot modify either their logs or their metrics, it's really complex to go one by one to structure that data, right? And make any data modeling on this is so complex, and the investment that any company has to do is big. So probably the question is there a real move today on creating solutions in the observability world that has AI to structure those type of non-structured data?
I think AI is a hot topic here.
Yes.
But I think the answer is much simpler than that, and that's going back to the open specification and open standards in the industry. And this is where I believe that OpenTelemetry is set to become the de facto standard. And you really see, and you were yesterday on the talk, but many of you that weren't in the talk, I showed some stats. You see all the major vendors, like all the cloud providers, Amazon, Google, Microsoft, all the monitoring and observability players, the Dynatrace and Splunk and Datadog and New Relic, and everyone is involved in OpenTelemetry. And you see them also in their offering, in their commercial offering, switching over from their proprietary agents and collectors and daemons into aligning with OpenTelemetry. And thanks to that, you see that you start getting OTel native integration, and also OTLP as the specification itself. So they even support natively emitting OTLP or ingesting OTLP in their backends. So I see the industry converging. We, for example, for a long time, were already fully aligned with OpenTelemetry. That's our standard way in our tool at Logs.io for collecting logs, metrics, and traces. But I see also all the other players going that way. So very soon, I don't know which vendors you work with, curious to hear, but many of them already offer, out of the pressure that they get from their customers, to support OTel. And once you have that, and the more we go about this direction of the industry converging with OTel, you will less and less have this pain of fragmentation of different formats coming from different sources, and you can align. In the meantime, the advantage of the OTel collector is that it doesn't mandate that you use OTLP. So you have many protocols that you can, many receivers for many protocols. So even if you still have a native, I don't know, Kafka logs that you want to collect or metrics, you just plug in the Kafka receiver, and similarly to what I answered for the previous question, after the receiver, it will then, from that point onwards, will already be OTLP aligned, and the rest of the processing will be uniform. So currently you have multiple protocols already supported out of the box, HTTPD, Apache, Nginx, whatnot. You ingest these, and then it's getting aligned. The rest of the pipeline already is standard OTLP.
Yeah, and probably the second question is just the question that he made. Is there any chance that probably next year we can have a workshop from end to end on how to apply really like data analytics, from emitting a metric, a log, to structure a log, and then make an analysis on that? I mean, I would love to see a workshop on that, to be sincere. Especially with legacy systems. Yeah.
I'm all in favor of having a workshop about that. I can actually tell you that we had a workshop last month in February in Amsterdam about observability. and how to do that. My company, so very small, we did that in collaboration with AWS in their offices there, so they were kind enough to give us, lend us their space. And we use OTel and the OTel demo app. OTel, by the way, you heard that yesterday on my OTel lecture, but for those who are not familiar, OTel has a canonical community demo. It's called the Astronomy Shop. It's like an e-commerce site. That's the architecture diagram that I showed before. We said the multiple microservices and multiple languages. That's the example app. So a lot of programming languages that are being instrumented with Redis cache and with Postgres and stuff like that. And the idea is to take this app, instrument it, build the dashboards, build the visualizations, alerts, and all the paths from zero to hero. So I don't know if this is the kind of things that you're looking for. So I'm trying to promote having more of these sorts of workshops. And the advantage of having a community demo is that each and every one of you can actually download and start playing with OTel without having to do a lot of manual work to just get started and get a feel for the how it looks like. So you have an application already, you see the instrumentation, you see the collector, you can start investigating the pipelines and so on. The legacy is very interesting. So, you know, Postgres, I know that there are lots of Postgres guys, so I don't want to call Postgres legacy. I'm very careful here. But you have some, as I mentioned, Redis, Postgres, so the reference third parties that you can't change, and still you can see how these are being instrumented. So it's a good reference. Of course, you can go to other types of legacies. And there are lots of discussions. There are also discussions about mainframe, how you use OpenTelemetry with mainframe, OpenTelemetry with edge devices. So OpenTelemetry today is far from just being for only the cloud-native microservice architectures. So, and you have lots of discussions, as I mentioned, running on monitoring bare metal and other use cases. So worthwhile following the relevant groups for the mainframe and others if this is the types of legacy that you're looking into. But and check out the receivers. Maybe some of the legacy that you're talking about already has someone already started writing a receiver for that, because it's just so many that I can't keep track. For example, our team wrote a receiver for SNMP traps. Okay. And then just a few months ago, someone from Cisco approached me saying how excited they are that there's a native receiver for SNMP traps. So I'm trying to convince them to start contributing to that. So yeah, it's definitely the path to go, at least my recommendation.
Thanks.
All right, give it him up.
We have a gentleman.
One more.
We have one more. So let's say he was been waiting very patiently, and I want to give him the time. And also, I'm sure that it's a very interesting question. So
thank you. I would like to ask, so one thing I've encountered in the past is that oftentimes I've had to look at logs or traces for like stateful processes of like a workflow. Say it's like an orchestrator, and it's like a Kubernetes that, you know, my thing starts up, it has all these different events, and they don't necessarily follow the structure of like a, you know, like a flame graph or trace. It's more like a state machine where it's like it's on, and it went down, and it went back. And I noticed there isn't a good view for me to look at that, or I don't really know how to aggregate that. What would you recommend?
So that it's less about the best practices here. It's more about tracing and applying distributed tracing for async workflows, if I understand you correctly. But I can tell you that there are quite a few that use tracing, distributed tracing with async operations, with Kafka type, even queued event-based schemes. So the idea is how to propagate the trace context in a consistent manner, and what's the parent-child, the causality relationship in the case of your flow. So, but it's definitely something that lots of material. So if you look at these sorts of like how it's done with Kafka-based flows and things like that, I think it's similar to what you're looking for.
Okay, thank you.
Sure.
Anyone else? Okay, let's give it up.
Thank you very much, everyone. And come for the stickers. I promised you stickers.